Okay, true, prove true for n equals 1. So that means, like, if you're looking at this, just a term there is, a term in n is n cubed, because you just get that from here, that's your term. And the sum to n will be 1 over 4, n squared, n plus 1 squared. Okay, so prove true for n equals 1. That means the left-hand side would just be the sum of the first term, t1, which will be equal 1 cubed, which is 1. The right-hand side is a quarter times n squared, n plus 1 squared. So it's 1 over 4. Now we're just summing one term, so where there's an n, we put a 1. So it's a quarter times 1 times 4, because that is 2. 2 squared is 4, which is 1. So therefore, left-hand side equals right-hand side. Therefore, true. So it is true for n equals 1. Okay, so we've got to prove true. We assume true. So assume for n equals k. So that means that 1 cubed plus 2 cubed all the way up to k cubed equals 1 quarter k squared, k plus 1 squared. And then we want to prove for n equals k plus 1. So we're required to prove that 1 cubed plus 2 cubed plus k cubed plus k plus 1 cubed equals 1 quarter k plus 1 squared, k plus 1 plus 1, which is k plus 2 squared. Because if you look at that, it's k plus 1 and then plus 1. That's where you get your k plus 2 squared. Okay, if you look at the left-hand side, now the left-hand side of this is the sum to k plus tk plus 1. Now the sum to k by assumption equals 1 quarter k squared, k plus 1 squared, plus the k plus 1 term. So that's k plus 1 cubed. So now if you look at this, you just look for a common factor. But before you can look for a common factor, you actually probably need to find a common denominator on this one here. And that would be, if you look at that, it would be 4. So this one has a denominator of 4, so this one's 4, and that's why you times the top by 4. So the common denominator is 4. If you take out a common factor of k plus 1 squared, you'll be left with k squared, the k plus 1 squared came out, plus 4, because that was from the common denominator, and it'll be k plus 1 to the 1, because we took out a k plus 1 squared, like that. So k plus 1 times k plus 1 will give you k plus 1 cubed. We've got the 4 there still, and we have k squared plus 1. Okay, so if you just expand that top line, just this one here, that would be 4k plus 4. So we end up with k plus 1 squared, k squared plus 4k plus 4 over 4. And if you look at that top line there, and you look at your prize, k plus 4k plus 4 all squared will give you the k plus 2 squared, k plus 1 squared's there, and then it's over 4, which is really just a quarter. So when you're looking at this then, that will equal k plus 1 squared, and then factorise this, product equals 4, sum is 4, so it'll be k plus 2, or k plus 2 squared, and that's over 4, which equals the right-hand side. Proven. And therefore, by the process of mathematical induction, it's true for all integer values of n greater than or equal to 1.